Here's a problem where we are dividing two rational expressions. These are fractions. Remember, when we divide fractions, we change the problem to a multiplication, and we change it to a multiplication by the reciprocal of the second fraction. We take the reciprocal of the second fraction, which means to turn it upside down, and multiply that fraction times the original fraction. Dividing can be done by multiplying by the reciprocal. Make sure I have enough space here for doing my factoring, so I'll move that down just a little bit. This fraction, remember, remains unchanged. And the second fraction, we're going to take the reciprocal of that fraction and multiply it times the first fraction. So now it's just a multiplication problem of rational expressions. So before we multiply, we're going to factor. Ooh, no binomials here to help us. Oftentimes we can get a better start when we factor binomials, but no such luck. So we're kind of stuck there. Well, let's look at this one as our starting point. In the trinomial, since this is a subtraction and this is an addition, that comes from two subtractions in the binomials. And we need to make a 7. What could we do to make a 7? If we have the 1 and the 2, because that'll make us plus 2. If we took the 3, how about if we did this? How about if we took 2x here and 3x there? 2x times 3x will give us 6x squared. Minus 1 times minus 2 is plus 2. Now watch how that's going to give us minus 7x. 2x times minus 2, that's minus 4x for the O-foil. Minus 1 times 3x is minus 3x for the I-foil. Minus 4x combined with minus 3x gives us the minus 7x. All right, we got one started. Now let's see if we can use that one to help us with any of the others. I wonder if this could be a factor of this trinomial. I wonder if 3x minus 2 could be a factor of this trinomial. I see a 3x, I see a 2, perhaps. So let's try that. Since this is minus 2 and minus 2 here, wouldn't I have to have plus 1 so that the L-foil would give me the minus 2? Minus 2 times plus 1 would be minus 2 under the L-foil. And then that would need to be x, so 3x times x is 3x squared. Will this combination give me plus 1x? It will. Plus 3x for the O-foil, minus 2x for the I-foil combines to plus 1x. And I now have one factor in common in the numerator and denominator that I can cancel. Well, let's see if maybe the 2x minus 1 would be a factor down here with this trinomial. I would like that to happen. Whether or not it will, we'll see. If that were the case, then if that's a plus 3, this would have to be minus 3, wouldn't it? So that the minus 1 times the minus 3 made plus 3 under the L-foil. And then if this is 2x, this would have to be 2x. So that the 2x times the 2x makes 4x squared. Now, will those two combine to give me minus 8x? 2x times minus 3, that's minus 6x for the O-foil. Minus 1 times 2x, that's minus 2x more. Minus 6x combined with minus 2x is minus 8x. And now the 2x minus 1 factors are canceling to 1. So now I've got to do some factoring here. Well, 2x minus 3 can't be a factor of that trinomial. 3 isn't a factor of 4. So I know that can't work. So if 1's going to work, it's got to be the x plus 1. So there'd have to be a 5x, so that x times 5x makes 5x squared. And if that's going to be a minus 4, and I've got a plus 1, it's got to be minus 4 in the second position of that binomial. So that plus 1 times minus 4 makes minus 4 under the L-foil. Now let's check the O and the I. The O-foil would give us minus 4x. The I-foil would give us plus 5x, which is plus 1x. And sure enough, The x plus 1 was a common factor that can now cancel. What's left other than the factors of 1? The factor of 5x minus 4 over 2x minus 3. And we have found that quotient. We found the quotient by first taking the reciprocal of the second fraction, taking the reciprocal of the divisor fraction, and multiplying it times the first fraction. There's our quotient for those two rational expressions.